All right, let's do some work with pH calculations and page 10. So what we see here in 1A is you are told this. So 1A. You are told you have a 4.5 times 10 to the negative 3 molar HBr solution. And you are asked, what is the pH of this particular thing? So the pH is what? Well, the first thing I would do, guys, is I would recognize the fact that there is an H in the front here makes this fall under the definition of the Arrhenius definition of an acid, right? So by definition, the substance is indeed an acid. Now, pH is a measure of the acidity. So that makes sense for hydrobromic acid. So pH is equal to the negative log of the molarity. In this case, 4.5 times 10 to the negative 3 molar, right? So you put that in your handy dandy trusty calculator and you get 2.40. All right, actually check that. You had 2 sig figs in your number, therefore 2.4. This doesn't get a label, believe it or not, and the reason it doesn't get a label is because pH is just measured in increments between 0 and 14. Now, 1B, though, is a significantly more tricky thing. And the reason for it is this. It gives you 3.67 times 10 to the negative 5 molar, but the substance here is KOH. Well, by definition, right, this thing, according to Arrhenius, is a base. Well, pH is the measure of the acidity, right? So, when you take the negative log of 3.67 times 10 to the negative 5th, unlike up in this problem where that was the pH, this substance is a base. Therefore, the negative log of this isn't the pH, it's the POH. So what you end up doing when you have that particular thing going on is you end up making, you get the POH. And what ends up happening here is the POH ends up being 4.44. Okay? But what ends up happening is that's the POH, and I wanted to know the pH, right? Well, luckily we know another equation, it's this. pH plus POH equals 14. Well, if the POH is 4.4, then you take pH plus 4.44 equals 14. You do the algebra on this, and you get pH equals 9.56. So what I really want you to get out of this teaching, and what we're doing right now, is the fact that you really have to evaluate what is the substance. It made sense here that HBr directly gave you the pH. But here, KOH didn't directly give you pH. It directly gives you the POH, the amount of base that's in it. And then from there, we use the second equation by plugging this in there to solve it for pH. Going to have to do that from time to time. By the way, for sig figs, 3 sig figs, because there were 3 sig figs here. The rest of this page takes into account some of those similar types of things. Now, number 3 on page 10 is a very interesting problem, so I would like to go through it with you. Okay. So with number 3, it says a solution is made by diluting 25 milliliters of 6.0 molar hydrochloric acid, right? So the substance is an acid, until the final volume is 1.75 liters. So the first thing I have to realize is that this is asking me for the pH, but it involves a dilution, right? So our dilution equation that we learned in class is M1 V1 equals M2 V2. Now, As we do this, I'll show you why that's imperative and important to us. But what ends up happening here is this. We started out with a molarity that was 6.0 molar. And you had 25 milliliters of it to start. Now we need our units to match. And it says milliliters over here and liters over there. So you can go either direction with this. I'm going to do it in milliliters. So 25 milliliters. What is the molarity now, M2, when the new volume, well, 1.75 liters would be 1,750 milliliters, right? So now we have congruent units. We divide both sides by 1,750. So divide by 1750. All right, so you do the math here, right? And you find that the molarity is equal to 0.085714 molar. Now the substance here is HCl, right? So by definition, that is an acid. pH is a measure, again, of the acidity of a substance. How acidic is it? Well, the substance is an acid. So therefore, I take the negative log of 0.085714. Notice, I didn't give a hoot about significant figures right now. When you take the negative log of this, now I'm going to care about sig figs. 2 sig figs, 2 sig figs, 3 sig figs. Therefore, my answer can only have 2 significant figures. Therefore, the answer is 1.1. And by the way, this was 1C, not problem number 3. It's just the third one. All right, let's look at 1D now. So 1D is a pretty tricky problem, but the thing you need to remember is this. This is moles per liter. Now, in letter D, you have 2 things that are given to you. You have 1.0 grams of HBr, and you likewise also have 1.0 grams of it's nitric acid, which by definition is HNO3. Nitrate, ate, and ick, right? So the first thing you need to do is you got to figure out the moles. Now since these are both acids, here's what's cool about this. You can turn these into moles and add them together. So for this one, all right, in order to do it, you would divide by the molar mass of HBr, which is 1.01 plus 79.90. On this one, right, you divide by the molar mass, which is 1.01 plus 14.01 plus 3 times 16, right? And you get a number on each of those things. So you get a moles here and a moles here, and I'll be right back with those numbers. All right, so you figure out the moles of each of these things, and as you could see right here, right, I didn't care about significant figures yet. I gave myself a whole bunch. So you had 0.0123594 moles of HBr and 0.015867978 moles. Now, because these are both acids, HBr and HNO3, the molarity would still be moles of acid per liter, right? So what you could do is you could take these 2 numbers and you could add them together. So that would be your moles. And you would set that over the liters of your solution, which in the problem was given to you, I believe, as 5 liters. Okay? Now when I do this, I'm going to, now let's go to 2 significant figures. So that would be 0.0056 molar. 0.0056 molar, right? Now remember, this is the molarity of an acid, here and here. Therefore, pH is the acid concentration, or the amount of acid. So that's cool because we can take the negative log of 0.0056. When you take the negative log of 0.0056, you end up with a number that is 2.2. Again, there's no label with it. It's just pH, 2.2. Now, real quickly, POH is number 2. Well, number 2 is pretty easy. All you got to do in problem number 2 is plug in your answers from problem number 1. So I'm going to do 1, and that'll be it. So this will be 2A. Well, we knew from 1A that the pH was equal to 2.4. Well, if pH plus POH equals 14, the POH would be 2.4, that's plugged in right there, plus POH equals 14, right? So you would solve it for POH, and you would get a POH, I'm doing this off the top of my head, I think it's 11.6. It would be as simple as that. You would do the exact same thing for B, C, and D. You can do that.